My name is Robert, and I am a Google developer expert for machine learning and for GCP. So for today, we'll be talking about considerations for deploying ML models on edge devices. So we're not going to go into the concept of training ML models, and we're not going to go into different types of ML models. We expect that that's more generic. So instead, we're going to talk about model deployment, but on edge devices. Now, there are all sorts of edge devices, but basically they have a few things in common. So first of all, edge devices are not full-fledged computers. So we're used to laptops, desktops, we're used to even phones and tablets. And those are relatively more powerful devices when compared to edge. So edge devices are things that they might be powering billboards, but they could be on your wrist. And that's one example that we have here. So a smartwatch is an edge device. It's a little bit different from a whole lot of other edge devices that don't have screens and keyboards attached to them. So they might not have input devices and output devices. But a smartwatch is a very good example for getting started. And that's because watches, as an example of edge devices, have certain constraints. The first constraint is storage. So if you come from a place where you are used to phones with large storage, you're talking gigabytes of storage. When you get to edge devices, you might not have that luxury of storage. The second thing is processing. So obviously you know that for you to have the kind of processor that you have in a computer, in a watch, you're going to need to have a fan, right? The processors on computers generate a lot of heat. They do a lot of work, but they generate a lot of heat. Instead, you have really small processors. Same thing applies to memory, not a lot of memory. And to cap it all up, and this is both a constraint but also a benefit, is that they don't consume a lot of power, right? So just imagine trying to run a battery for a whole day on, a laptop for a whole day on the battery that you have in a watch. It's just not going to work, right? It might not even run for 5 minutes. So when you take all of these constraints and you start to think about them, then you then say, how do we compare these edge devices to standard computers? And then how do we get things that work on standard computers to work on these edge devices? And then how do we get ML models that work on standard computers to work on these edge devices? So the smartwatch is one good example of an edge device, but a lot of the time you have some single board computers that are also used as edge devices. And the example up here is the Raspberry Pi 4, but you have the Pi 3 and the Pi 2 still in production, and they're heavily used. Sometimes you find them powering signages and billboards, but you also find them in deep industrial applications. They still have the same constraints that we're talking about. The processors are pretty small, they're limited. The RAM is limited. The memory is limited. Here, you have to use an SD card, so it doesn't compare to a hard drive. Another example is this is from Arduino. So if you're used to Arduinos, this looks completely different. And it's nowhere as large as what you see on the screen. This is blown up. It's pretty small, about the size of an SD card, not the micro SD, but the SD card itself. But it comes with all sorts of things. It has a camera on it, and it has some sensors. It has a bunch of sensors on it. So these three devices are all frequently used as edge devices. What can you use them for? If you take this, for instance, you can actually build a smartwatch with this because it has the sensors that you need for activity detection. You can use it because it has a camera. You can use it for all sorts of applications that require detecting anything. So any image classification task can be run on this. If you have one that has a microphone, then you can use it for natural language processing. The Raspberry Pis are frequently seen in industrial settings. You can have them monitoring elevators to find out whether or not they're running properly. So I've mentioned that you can use the last one that we looked at, which was the NICLA. You can use it for object detection. But we all know that when we start talking about object detection, that's when we're talking about machine learning, right? And there are other applications that you need to use machine learning for. But then, what are the requirements? How do you get an ML model onto these things? We've already said that they've got weak processors, they don't have a lot of storage, they don't consume a lot of power, right? So when you start to think about deploying ML models, you need to also have certain things in mind. The first one being low latency. So you don't want the device talking to an ML model in a remote location. You want the ML model on the device. That's what low latency means. Secondly, you have to think about offline availability. So we've said that these things are edge devices. It's possible that they might not even have internet access, right? So if there's something that they need to do, they should be able to do it with or without internet access. And then we have concerns nowadays about privacy. So if you need to take data and send it somewhere else, people start to ask, what are you doing with my data? Where are you storing it? Where are you processing it? How long are you storing it for? When do you get rid of it? How do I know that you're getting rid of it when you tell me that you're getting rid of it? So you also need to think about privacy. Don't send data anywhere you don't need to send data. So with all of these considerations in mind, we then know that the models that you're building have to be customized for the system. We've said that the processor is not as capable as what you have on the desktop, so these models need to be small, but they also need to be efficient, right? They need to work on the hardware. The problem with edge devices is that they're not all the same. So what you need to get things working on a Raspberry Pi is completely different from what you need to get it working on the NICLA, for example. So you need to target. And then whatever model you have, you need to shrink down to be as small as possible. And that's a process called quantization. Now, like I said, we're not going to go into model training, right? We don't have time for that. Yes. So we're going to say that these things that we've mentioned have been taken into consideration and a model has been trained. And that actually happens. So there's a TensorFlow model garden that you can go and find some devices, some models that have been pre-trained that you can get started with. So we're now going to talk about how you take some of those models and put them on a target device. And the first thing that we're going to talk about is the TF Lite task library. So this library, it works on Android and iOS devices, but it also has libraries for Python and C++. What that means is it will work, you can write code that will run on a lot of edge devices. So if Raspberry Pi, for instance, is programmed using Python, but Arduinos are programmed using C++, and there are also other edge devices from ST, for example. Those are all programmed using C++. So if you make use of the TensorFlow model garden, you can find models for computer vision, for natural language, and for audio. Next slide, please. And so this is what it looks like. So if you go to TensorFlow Hub, you can then look for models, you can search and filter. If you choose TF Lite, so TF Lite is a smaller constrained version of TensorFlow, you will find models that conform to the TF Lite model. So these typically you can deploy on phones, but we'll talk about deployment on a Raspberry Pi, for example. Next slide, please. So you can take any model from there and download. And next thing you want to do is, we're working with Python, so what you want to do is install the TF Lite support module. Next slide, please. Now, once you do that, you can jump straight into code. It's not a lot of code. So what you're doing is you're using the task library, and that's the TF9 support. So you can um, import vision. So in this example, we're going to work with a computer vision model. You can import vision, and then you can import core. And then you can go ahead and start working with the classifier straight up. So what you do is you use the vision.image classifier.create from file, and you point at that model that you downloaded from the hub. Right? Now, once you do that, you can go ahead and start running inference. So in this example, you're running inference from an image on a file. Now, it's always a good idea to just simplify your process and put a file, whether it's an image, whether it's a video, whether it's a sound recording. It's easier to start with a file on the device, and then you get to the next step. So in the code here, you'll just point at an image file, and then you can run your classifier. And next slide, please. Now, once you do that, you will get a result. And because we're dealing with an image, this is an example of a classification problem. You will then get a result set that looks like this. And because it's a pre-trained model, it's going to be giving you a result set based on a number of classes that the model was trained on, right? But don't worry, you can retrain the model using your own images. So you get a result that looks like this, and then this is, of course, something that you can interpret in your code. Next slide, please. So remember I said you can retrain the model, right? So it's often the case that, yeah, I have a computer vision problem, but I have a problem where I need to classify images that weren't part of the original training data set. And so when that happens, you start to get poor performance from the original model. And so this is where transfer learning comes in. And that's what the TensorFlow Lite Model Maker is about. So without the TensorFlow Lite Model Maker, you'll have to go all the way back to TensorFlow, take a large model, but preferably a small model, because you really want something that you don't have to shrink too much. So you'll take a model, but something that is state of the art, and then retrain it, and then you'll now have to convert it to a TensorFlow Lite model. But with the TensorFlow Lite Model Maker, you can retrain a set of models, and on the screen we have the types of models that are supported. So obviously not everything out of the door is supported, but you have a good number of options that are supported. Next slide, please. Okay, so on the slides we can see the kinds of models that you can retrain with the TensorFlow Lite Model Maker. So everything from image classification, object detection. One challenge, though, is that not all edge devices support all of these. Not all have the capability. So while we're talking about these devices not being powerful, you also need to note what sort of task you want to make them carry out. So things like audio classification don't require as much processing power as things like object detection, for example. Next slide, please. So to use the TensorFlow Lite Model Maker, and in this next example, we're going to work with speech, so natural language processing. So first, we saw an image example. Next, we're going to see speech. So for that, you need to install libport audio, because that's what handles your sound files. And then you need to import the module TF Lite Model Maker. Next slide, please. Okay, so now on this screen, forget the fact that there's a lot of text. It's really just imports. So you'll import a bunch of things, and on the next slide, please. Okay. So on the next slide, you can go ahead and start to work with it. So, okay, actually, I went back to images. So here, you'll use a data loader, but you'll read from a folder. Okay, yeah, we're doing a pre-trained model. We're retraining a model, actually. So to retrain a model, you'll need a folder with your images, right? So you'll have a folder, and in that folder, you'll have your subfolders named with the classes of the images that you're using to retrain your model. And then you can set up a data loader. So the data loader will recreate a pipeline that feeds the data in. So the keynote here is that we're retraining a model, we're fine-tuning a model, but you're not having to write TensorFlow to do all of that. Instead, you're handing it off to the model maker. And so you can see on the second line where we do a train test split, because you always have to do a train test split. And then you then call the image classifier.create and pass in the training data, and it will run the necessary number of epochs to fine-tune your model. And then afterwards, you can evaluate the model for accuracy, and then you can export that model, right? And we just export it to the current directory that we're in. And once you do that, you have a new TF-like model that is fine-tuned for your own application. So in this next one, we're going to take a look at TensorFlow Lite, and this code will work on Raspberry Pi 2, 3, and 4. Next slide, please. So here, what you want to do is, we've seen all of these, of course, except for OpenCV, right? So again, you can go back to your TensorFlow Hub and pick up any models. So this time around, we're going to look at an example of processing sound, and we're going to do it in 2 stages. So we're going to go pick up YamNet. YamNet is a model that classifies sound into certain categories. So here we will install audio, core, and processor. And then we'll take that YamNet TF-like model and instantiate it as a classifier, right? Now we will start, remember the advice, always start with a downloaded file. So we'll have an audio recording in WAV format, and then we can load it up. And notice the third to the last line where we have audio file. Audio file is audio.tensoraudio.create from WAV file, right? And so what that does is it takes that sound file and it converts it into a binary representation, which is called a tensor, right? And then you can go ahead and just run classification on it. Next slide, please. Of course, when you run your classification, you will get a result that you can then process. So similar to that first output, that text output that we saw, you'll have something similar, right? Now, once that works, what you want to do, and this is the point behind edge devices, right? Once that works, edge devices are meant to run one task repeatedly. So in the event of sound processing, you might want to have a device that is listening for sounds and that does something when a certain sound is detected, right? So it could just be, oh, I have machinery. Machinery runs normally, nothing to report. But when I detect a sound, like the machinery starts to grind, or it starts to whine, or it starts to do something, I want to trigger an alert, right? So that's an example of something that you would do with an edge device and a microphone. So now let's stream from a microphone. So to stream from a microphone is similar to what we did, right? We will instantiate our model. So we'll still use YamNet. But now there's something new that we introduced. We introduced a recorder, right? And if you use something like a Raspberry Pi, you can just connect a USB microphone. But when you call classifier.createAudioRecord, it knows to go at the OS level. It knows to go and pick up that microphone or any sound device that you have. It will pick it up. And then in the next step, you instantiate a tensor from your classifier, right? And then you start recording. So you tell the recorder to start recording. And what it does is it just continuously listens to that sound input. So this is the difference from your audio file. Audio file, it just does it once. It reads it once, extracts a tensor. With this, it starts reading. So once you start reading, the next thing that you want to do is just check for a condition, right? So when you read from a microphone, you actually store in a buffer. And what you're doing here is you're saying every half second, go read that recorder and put it into the buffer as a tensor and then run classification on it. So it's actually pretty straightforward. Of course, the underlying implementation in hardware and other things is a bit complicated, but it's pretty straightforward. It's the same thing you would do if you have a camera, right? So if you have a camera and you're saying, oh, I want to know if a human being crosses this place because human beings are not supposed to cross, you'll just have the camera constantly looping and reading video and streaming, and then you'll just be checking, every second to see if something comes up. So that's really it. That's an example of using TensorFlow Lite and the task library and the model maker and deploying models to edge devices. So in this example, we use the Raspberry Pi and retraining a model. So pretty straightforward. So far, no TensorFlow. So I guess at least one person is happy. Questions?
For the last one, you have been working on like a model that can capture the room and then explain the room. Like, okay, there's a speaker on this side, there's this on this side. Then he converts it to audio. So you like if it's a blind person, he just pushes the button and he says, okay, there's a speaker on this side, walk like this. But now I just have it on my Jupyter Lab notebook and okay, there's deploying, but there's nowhere to put the application. Like it's just on my Jupyter notebook now. I just run it locally and I've deployed it, but there's no front end. There's no like how how do I like actually produce it as an application or something?
So if you're not an application developer, you can't build an application out of it. But you can put it on GitHub and put notes and say, here's a model that does X. Use it when you need it. And people will find it when they need it.